Hi, this is Mr. Lesage, and this video is to help students in the Math 8B course with their performance task. This is the performance task here, Business Success. As usual, you should take this document and download it to your own computer. You should create a Word document so that it's not read-only and that you can save and go back to this document. If you download it, it'll come down as a read-only document. Assuming that you've gotten all of that done, then you get to the first question. And the first question is, you have some data here in this table. You need to graph it in this graph, or you could use your own graph paper if you wish and do it separately. And then just go back and put your points here. For students who are not sure how to put points on a graph like this in Word, if you go to Insert, Shapes, and take this little circle shape, make a small circle, then you can take that point and you can move it all over the graph wherever it needs to go. So you can figure out your scale and you can add your point wherever it needs to go. And then you can continue to add more points for each one of the data points here. Then it says, do you notice clusters or outliers? So once you have your graph, you're going to answer that question. And how would you describe the correlation? You've gone through that in your lesson, so you'll know which words to use for the correlation. Is it strong or weak? Is it positive or negative, for example? And then finally, you have to identify the independent and dependent variables in your graph. Now, that's sort of the hard way to do these problems. When you get to the second one, you now have to take a look at the data that's already here on the graph and look at the correlations and draw a trend line. So let's talk about that trend line process, and we'll talk about then perhaps an easier way to do these problems if you wish to do that. All a trend line is a line that approximates, especially a linear trend line, it approximates the straight line that would most closely align with those points. So again, if I go to Insert and Shapes and pick just my line tool, I can try to find a line that would kind of match up with these points. If you look at where I've drawn this line, all of these points are slightly below. These are a little bit above. That may be fairly close. I may want to take this line and slide it down so it aligns to these points a little bit better. I might want to slide it up a little bit so that I end up here. I might even want to take this end and slide it down. Oops, I want to just slide that end down here a little bit, have a little bit different angle. And this is just eyeballing the best line that you can. That's why we call it the best fit line. You're trying to fit the line in with all these points. And the way I look at it is you want the same amount of distance from the line down to the points that are below the line as there is space from the line up to the points that are above the line. And that's something you just have to look at and try to do the best to make it fit. Everybody will probably come up with a slightly different line, but they'll all be pretty close. Once you have the line in there, then you certainly could figure out what the equation of the line is. You can see where the intercept is. You could take a couple of points that are right on the line and figure out the slope of those and use the slope-intercept form of the equation for a linear equation to come up with it. Now, is there another way to do it? Is there an easier way to do it? Well, there certainly is another way. We can go to Excel. As you can see, this is Microsoft Excel. I have taken the data from this problem. This is problem number 3. I've taken the data from that problem and no, it's not that problem. Which problem did I take here? Let me find the data. It's the data from this one. So sorry. It's the data from this one. And I've put it into this table. So you can see all I've done is just copy these over to here. I then did an operation where I highlight all of the data, and I go to Insert again. And this time I'm going over to Charts. I'm going to insert a chart, and I picked this chart right here, the scatter plot. And when I clicked on that, I got this chart to show up. So there are all the points already graphed for me. Now, I could either take that graph and copy it onto my Word document, or I could just replot all of these onto this graph, whichever way you'd like to do that. Now, with that, I can begin to identify some things. I can see that a line of best fit is going to go somewhere here, and this point then becomes the real odd point. And there's a name for that that you should have seen in your work in this unit. Now, if you notice, there's also, when I do this, I have a choice of whether I just want the points, which is, you can see what I've done right here, or I can say, give me the points all connected with lines, which you see here. That's kind of a mess. In this particular case, it doesn't seem to help me out very much because there's lines going all over the place trying to connect all those dots together. However, one of the advantages of doing it that way, and I want to slide that chart up now so you can see it, one of the advantages of doing it that way is I can click on the line. This is a right-click action that I'm doing now. So put your cursor on the line, right-click, and you can see I get this screen. And if I say Add Trend Line, and then say that it's a linear line, a linear equation that I want defined, and I want to display the equation on the chart, so I click there also, then I will get a line drawn in, and that's what you can see here with the dotted line, with the equation for that line. So that's a pretty nifty way to be able to take your data, get it plotted on a chart, and then also get the equation for the line as well. Now, we would never be this specific when we're trying to eyeball in our data. We would never, I don't think, come up with a y-intercept of 81.799. It's more likely we'd come up with something like 80, which is certainly close enough. And over here we might end up with, oh, I don't know, maybe negative 0.5, negative 0.1, something for our slope. So it would just be a matter of finding 2 points that are fairly close on the line. For example, maybe this point and this point. Our line has pretty well gone through those two. So we would just use the y2 minus y1 over x2 minus x1 formula for calculating the slope between 2 points. So we can either do all the work by hand, the way we were doing here with the insert. Remember, we're inserting a shape and we use the dot and we just put the dots to correspond to all of these. Or we can do the Excel version where we move the data to a table and then highlight the table, insert a chart, and come up with a chart that way. This is also very handy, this method of working, if you're looking for other types of graphs. When you get to algebra and algebra 2 and you're looking at quadratic graphs or exponential graphs, those kind of functions, this is a very handy tool for finding those equations as well. You can also do that on a calculator, on a graphing calculator, by using the regression functions on the calculator. You could also do this problem with the linear data and do a linear regression on a calculator. If you have a calculator like TI-84 or 85 or 86, you can find directions on the internet for how to find the regressions using that calculator. So I hope that information helps you along the way to do this performance task. again, in this case, since we don't have the raw data, it's best just to eyeball it in and do it that way. In this problem, though, where we have the raw data, we could certainly take that, key it into Excel, and do just like I showed you for the last problem. All right, good luck on your performance task. I hope that has made it a little bit easier. One last piece of information in this last question where it says, explain how to use the regression calculator to make a reasonable prediction given the data table. It's not necessary for you to go find a TI 83456 calculator, go out and buy one. There are regression calculators all over the place on the internet. For example, I have pulled one up here. You can see the website here, www.easycalculation.com/statistics/regression.php. Or if you go to easycalculation.com, you can find the regression calculator. But you can see what you do here is you put in X and Y values. There are not nearly enough places here as there were numbers in the table. To add more numbers in, you just click here, get all the X and Y values in. When you're done, click calculate, and it will calculate the slope. It'll give you the y-intercept, and it'll give you the regression equation, just like you do when you do the Excel version and right click on the line. It will do it the same way here, and this is what they mean by linear regression calculator. Alrighty, good luck, and I hope that gets you through the performance task for your Math 8B course.